So recall that log of 100 means 10 to the what is 100. Logs tell you the exponent. That would be 2. 10 squared is 100. 10 cubed is 1,000. Notice that this is log of 100,000. Notice you can just add up the number of zeros. And log of 100,000 is 5. So be careful. Notice that log of 100 times 1,000 is not log of 100 times log of 1,000. That would be nice if you could just split it up that way, but it's not multiplication, it's addition. And that's because multiplying in the exponent, multiplying in the real world is adding in the exponent. So and notice another thing is that this is true in any base. So I did it with base 10 because we have a button for it, but that's not what it has to be. So what about, let's write this down. Log of a multiplication splits up into adding. And also notice that adding two separate logs combines into multiplication inside a single one. Multiplication inside addition of two separate logs. Log of a division multiplication splits up into addition, division splits up into subtraction. So, what about log of a squared? If you split it up into log a plus log a, it is just the same as 2 log a. Now we had a set of notes a little while ago that was showing why this works, but in general, note that exponents inside is multiplication constants outside. I'll write that down.
Squish. It says multiplication.
So we have testing the prediction. I'm going to say we don't want addition inside. We want multiplication. And that splits up into addition.
Second, separate logarithms.
I gave you some numbers to use. 0.4771 for log of 3 and 0.3010 for log of 2. Calculator says that adds up to 0.7781. We check with the calculator. We have a log base 10 button, so we don't even need the change of base formula. And sure enough, on the calculator, log of 6 is the actual thing. What about log of 8? Well, just like 2 squared splits up into 2 times 2 and then splits up into 2, adding 2 separate logs, log of 2 cubed turns into 3 log 2.
Oh, 9030. No wonder. Oops. I'm an idiot. Wonder if I can fix that. Hold on.
Up to round off error?
Try and put... Let me just see if I can fix that. Hold on. That's a 3. Okay, back to our regularly scheduled program.
That's exactly what the calculator says we should have. 30 is, well, let's see, 2 times 3 times 5. Uh-oh. We don't have log 5. But what we do have we do know that log base 10 of 10 is 1. Okay, log base A of A is always 1. So I'll split 30 up into 3 times 10 instead. And remember, it's multiplication inside, and so it's addition separately. Okay, and the calculator agreed. All right, so let's practice splitting things up. ln3 plus ln x cubed plus ln y squared. The main operation was the multiplication, so we split it up that way. And then we pop exponents. We've done popping exponents in a previous problem set, but we need to keep practicing that. Okay, so that's separated.
Division inside, subtraction outside.
Division inside is subtraction outside. And the exponent can pop down as soon as we write what it is.
Exponent for square roots.
Okay. What about this one? Okay, we've got lots of exponents going on. Remember, cube root is 1/3 as an exponent. So what we have then is 1/3 ln x squared y to the 5th. Now I can pop those apart. And I'm going to pop the exponents down in front at the same time. And I can redistribute if I want. The combined exponent for x is x to the 2/3, which I can keep popped down in front. And then 5/3 ln y for cube root of y to the 5th. Going backwards, we start by popping exponents inside. Then we figure out what they are. 2 cubed is 8. And the exponent 1/2 is for square roots. And then we combine in multiplication. This one is tricky, but 2 is ln of something, ln of e squared. So we have ln e squared plus ln y minus ln z. Addition combines into multiplication, and then division for the subtraction. Same thing here. This is going to be ln of e to the negative 1. What's the exponent of 2/3? Remember that it's cube root and square it. So 1 over e times the cube root of x squared, the e can pop into the denominator. And there we go.
Just one fair word of warning. If you have oops. Come on. Oh, it just stopped again. Oh, I put the wrong one. If you have lnx, oh, stop it. lnx minus lny, subtraction outside is division inside a single a single logarithm. ln of x over lny is different. It's the change of base. Log of the number divided by log of the base. So you got to be careful, put it inside a single logarithm when you're turning subtraction into division. It's not two separate logarithms. That's the change of base formula.